All right, everyone. Okay. Right, we're looking at finding the equations. Okay. Finding the center. Okay, and radiuses of circles. Right. So, a reminder. So, in order to find the equation of any circle, the center of any circle, and the radius from an equation. Okay. Remember, the center of the circle has coordinates, x coordinate of a and a y coordinate of b. Okay, and if we have a radius of r, then the general formula for the circle is x minus a squared plus y minus b squared is equal to r squared, right? So now, okay, in this particular case, okay, so in order to find the coordinates of the center and the radius, you need to rewrite the equation so that it's in that form. Okay, so starting with a, you've got x squared plus y squared is equal to 16. Well, you should recognize that's an equation center origin, but let's just say you forgot. It means x minus naught squared plus y minus naught squared is equal to 16. So your center is naught naught, okay, and your radius is equal to the square root of 16, which is equal to 4. So that one's pretty straightforward. Okay, for b, we've got x minus 4 squared plus y plus 3 squared is equal to 18. So if we link it to that formula, remember the center in an equation, it's because that's a negative, it's the opposite sign. Okay, so your center is going to be 4, opposite sign, minus 3, that's the coordinates of the center. Remember, this number is r squared, not r. Okay, so that number is r squared, so r is going to be equal to the square root of 18, which is going to be 9 times 2, which is 3 root 2. Okay, so those ones, pretty straightforward, but it's important, okay, that you're able to recognize, okay, what's happening there. Okay, right, then, if we go to question C, okay, in question C, right, we've got this equation over here. Well, you've got to write it, always get your first step is get all the x's together, get the y's together, okay, and then get the numbers on the other side. Okay, so get the x's together, get the y's together, rewrite the equation so that you have that scenario over there. So in this case, I'd rewrite it as x squared minus 6x plus y squared plus 5y is equal to 4. Right? Now, the next thing you want to do is set it up like this, because you want to get, your objective, remember, is you want to get the equation in this format over here. So when I do these sums, say therefore, I want to end up with, I always write it like this, x something squared. Then I'm going to deal with the y's, plus y something squared. And then, so I'm going to force numbers in there. I call this forcing and balancing. I still got that 4 over there. But then you're going to have to, by forcing that number in, you're going to have to plus, you're going to balance something because of this. You force that in over there, a number in over there. And you're going to balance, okay, something else. So you're always going to have 2. They're always going to be positive, okay, because you balance something from this over here. So, I should really say from that. So what goes in the bracket? Well, in order to get back to x squared minus 6x, what you're always going to do is take this number and divide it by 2. So you're going to say negative 6 divided by 2 is negative 3. Okay, so negative 6 divided by 2 is negative 3. So you're going to have x minus 3 squared. Now, by forcing that number, if you times this back out, square the first term, you get x squared. How do I square a binomial? Times together and times by 2, I'd get negative 6x. But now, negative 3 squared is positive 9. You've unbalanced the left. You've added 9 to the left-hand side of the equation. So to rebalance it, you've got to add 9. Think of those old scales to the right-hand side of the equation. Okay. Then with the y's, okay, you're going to take the coefficient always and divide it by 2, just like you divided this one by 2. So 5 divided by 2 is going to be plus 5 over 2. If you squared that back out, you get y squared times them together times by 2 plus 5y. Okay, then 5 over 2 squared. So effectively, if you times it out, you get 25 over 4. So you've added 25 over 4 to the left-hand side. So I must add 25 over 4 to the right-hand side. Okay, hope that makes sense. Right, then, okay, you're going to calculator. Add the things on the right-hand side. So you're going to get 13 plus 25 over 4. And that works out to 77 over 4. So you're left with x minus 3 squared plus y plus 5 over 2 squared is equal to 77 over 4. Okay, so that is your equation of that circle. It's the same equation as that, rewritten in that format. The advantage of that now is I can follow out the instruction, and the instruction was what's the center of the circle. Well, now it links up with that over there. So I can say, right, that must be equal to the center. A is going to be, remember, it's the opposite sign. The center is going to be 3, opposite sign, minus 5 over 2. And your radius is going to be the square root of 77 over 4, which simplifies to root 77 over 2. A reminder of the steps. Get the x's on their own, y's together, numbers on its own. Set up your brackets first. Okay, don't forget you're going to have to balance with two things. Always divide that coefficient, okay, of the x and the y term by 2. Right. Then, if I take the last question, okay, same logic we're going to use. Okay, in this case, the x's and the y's are together for question D. The only thing we need to do, okay, is get, so you're going to have x squared plus 2x plus y squared minus 10y. Get the 1 to the other side, it becomes minus 1. How do I set it up? You're going to say, right, I've got x something squared plus, I'm going to work with that for the x's. Set it up like this, it's easy. Plus y something squared is equal to, well, you've still got this minus 1, but then you've got to balance with the x bracket, because you've unbalanced the left-hand side, and you've got to balance with the right bracket, so you rebalance the right-hand side. Okay? So what goes into the bracket? Well, you simply take here the coefficient of x divided by 2. 2 divided by 2 is 1. 1 squared is 1, so I've added 1 to the left-hand side, so I must add 1 to the right-hand side. Okay? Then you take y, divide that by 2. Negative 10 divided by 2 is negative 5. Okay, I've unbalanced that side by negative 5 squared. Negative 5 squared, I must rebalance by adding negative 5 squared, 25. Remember those old-fashioned scales? Remember you've got those scales like this. You've added 25 to that side, so you've got to add 25 to that side over there. So you end up with, therefore, x plus 1 squared plus y minus 5 squared is equal to 25. Now you've got it in this format over here. So your center, opposite signs in the bracket, is going to be minus 1, 5. And your radius will be the square root of 25, okay, which is equal to 5. This number, remember, is the radius squared. Okay. Righty. Next page. Right, so it says here, a circle, okay, with center m minus 5, 2 touches the y-axis at E. Now remember, if something touches the y-axis, it's a tangent. Okay? And if it's a tangent, the angle, okay, between the tangent and the center is going to be always equal to 90 degrees. Okay, so the angle between your tangent and your center is always equal to 90 degrees. So that's 90 degrees over there, but you could have seen that, even if they didn't give you that, that's 90 degrees over there. So before you even look at the question, what is it? What have we got here? Well, first of all, this distance is your radius, and this distance over here is, this distance here is also, okay, your radius, right? So that's also your radius over there. Okay, so because that's a right angle, it's a horizontal line, okay, which means your radius is simply this distance over here, the horizontal component of that distance. That must be a horizontal line because of those right angles. In other words, this y coordinate, this coordinate of E must be 0, and the same y coordinate there, which is 2. So E is the point 0, 2. Fill in what you can before you even look at the question. The x coordinates of these must be the same. So f must be -5. Okay, remember from geometry, a tangent, we've got this theorem. A tangent is always perpendicular to your radius. Okay, tan perpendicular to radius. So because it touches, it said the word touches over here, a circle touches the y-axis. Touches means it's a tangent. Okay, and tangents are always perpendicular to radius. You're going to have to use that reason, tan perpendicular to radius, okay, even though this is, okay, analytical, we still have to give that reason over there. Right, now let's think about it. So, this only has a horizontal component, this line, so the distance of the radius must be the same distance as the distance from M to E. The y coordinates are the same, so the only distance moved is the x coordinates. So from -5 to 0 is 5 units. So we know that your radius is going to be equal to 5 units. Okay? Haven't even looked at the question yet. Which means what? If this y coordinate is 2 and your radius over here is equal to 5, it means you've gone 2 minus 5 down. So this must be the point -5 minus 3. Okay, so if something touches something, the tangent, that's a right angle. Okay, if it's parallel to the axis, the x-axis, it means your y coordinate would be the same. Okay, this is a right angle again, so it's a vertical line. That's why the x coordinates were the same, and the distance is only a vertical component. So it's first of all, write down the coordinates of E and F. Okay, so for number 1, the coordinates of E is 0, 2 over here, and the coordinates of F, always fill things in your diagram. Okay, we discussed it. The coordinate of F is -5. 2 minus 5 was -3. Okay, right, then it says determine the equation of the circle. Well, how do I go about this? It's nothing new. How do I find the equation of the circle? Remember, first write the general formula down. I've got x minus a squared plus y minus b squared is equal to r squared. Do I have the center? Yes, I do. So a must be -5 and b must be 2. Okay, so my center is -5, 2. So that's a and that's b. And we've discussed that your radius, that's a horizontal line, so we said that the radius must be equal to 5. Okay, so the equation then is going to be, if I sub those numbers in, x minus -5 squared, in other words, x plus 5 squared, opposite signs, plus y minus 2 squared is equal to my radius, which is 5 squared, which is 25. So there, okay, is the equation of my circle. Okay, determine whether the point -3, 6, okay, lies inside or outside the circle. So -3, 6, we're not sure exactly where it is from this diagram, but it's -3 and somewhere up here. So it's going to be roughly, okay, let's get rid of that nonsense. -3, 6 would be somewhere, well, I'm not sure whether it's there, or there. But we do know that the coordinates, okay, so that M is the center, okay, and the coordinates of this point, I'm not saying it's outside, I'm just writing it down here, is -3, 6. So what I'm going to do is I'm going to find the distance from the center to that point. If the distance from the center to the point, okay, is bigger than the radius, it must be outside the circle. If it's equal to the radius, which is 5, it's on the circumference. Okay, and if it's less than 5, it's inside the circle. So you're going to find the distance between, so for question 3, you're going to find the distance between M, let's call this point P. Okay, where M is the center, which has coordinates -5, 2, Okay, and P is this point, -3, 6. So, to find the distance of MP, we're going to use the distance formula, which is on your formula sheet. Okay, it's going to be x1, y1, x2, y2. And the formula says it's x1, which is -5, minus x2, which is, so it's -5 minus -3, which becomes -5 plus 3 squared. Okay, plus y1, which is 2 minus 6 squared, which gives you -2 squared is 4, -4 squared is 16, so I get 4 plus 16, which is equal to the square root of 20. Okay, and the square root of 20, okay, you can check it on your calculator. Okay, the square root of 20 is equal to, I haven't got my calculator here, square root of 20, well, it's not, it's 4 comma something, okay, because square, so it's 4 comma something, okay, which is less than 5. Why does 5 matter? Because 5 is your radius, right? Okay, so the distance is less than 5. So in other words, P must in fact be inside the circle, because the distance between M and P is smaller than 5. Okay, if it's bigger than 5, it would be outside the circle. So it's the distance between M and P is smaller than the radius, so therefore lies the point -3, 6 lies inside the circle. All right. Okay, hope that makes sense. Right. Now it says, if a circle is drawn through points M, E, and F, let's just clean this diagram a bit. Okay, so a circle goes through M, E, and F. Okay, determine its equation. So, first, a circle through M, E, and F. Remember, M has coordinates 0, 2. F has coordinates -5, -3. Now I've got a circle, okay, which goes through M, E, and F. Let's make it a bit clearer. Okay, a circle going through M, E, and F. All right? And they're giving you a big fat hint here. They said the diameter of a circle subtends an angle of 90 degrees. So in other words, this angle over here, so remember you've got the theorem that says if you've got, okay, a diameter, any angle it subtends on the circumference is 90 degrees, right? Okay, angled in a semicircle. But likewise, let's erase this. Likewise, if you have, okay, so for question 4, if you have any chord and the chord subtends an angle of 90 degrees, what that means is this chord, so if you're told that's 90 degrees, it means that this chord must be a diameter. Okay, reasoned in geometry is always what you got, so your reason here would be chord subtends 90 degrees. That's why you could say AB, so your statement would be AB is a diameter, and your reason would be chord subtends 90 degrees. So that's a geometry reason which can be pretty useful. Remember, if you're not told it's a diameter, you've just got a chord, but that chord subtends 90 degrees. The conclusion is that this line AB over here, okay, must be a diameter. Okay, why is it a diameter? The reason is because you've got a chord which subtends 90 degrees. In geometry, okay, we always give reasons what we got, not where we're going. Okay, so we're going to use that in this question. So what have we got here? Well, we've got these 3 points, E, M, and F, are all points on the circumference. And if you join up these two over here, E and F subtend an angle of 90 degrees. Okay, and because E and F subtend an angle of 90 degrees, let's undo that. Okay, it must mean that this bit over here in green is a diameter. So that's the diameter over there. Okay, because it subtends 90 degrees. So your first statement will be EF for question 4 is a diameter of the circle. Why is it a diameter? Because you've got, okay, a chord. What have you got? A chord which subtends. That's your reason. You've got to give reasons. Chord subtends 90 degrees. Right, so now you know that that green line is diameter, which means that the center of that circle will be the midpoint, okay, of your diameter. So the midpoint of the point 0, 2 and negative 5, 3. How do I find a midpoint? Remember, I'm using this formula, x1 plus x2 over 2, okay, y1 plus y2 over 2. So if you add the x coordinates, you're going to get x1 plus x2 over 2 is going to be minus 5 plus 0 over 2. The y coordinates, add the y coordinates, minus 3 plus 2 over 2, which gives you a center of this circle as being minus 5 over 2, negative a half. So now you've got the center of the circle. The question is go find the equation of that red circle. So to find the equation of that red circle, you're going to say, okay, how do I find the equation of a circle? I'm going to go x minus a squared plus y minus b squared is equal to r squared. But you know the center of this new circle, there it is over there, it's minus 5 over 2 minus a half. So it becomes x plus 5 over 2 squared plus y plus a half squared, okay, is equal to r squared. Okay, but I need to find r squared, so pick a point. I'm going to pick that point over there, 0, 2. You've got to pick negative 5, negative 3. So I'm going to sub in 0, 2. You can do it in one step, but sometimes people then get confused. So I'm going to get 5 over 2 squared, because x is 0. Okay, and then plus 2 plus a half squared is equal to r squared. And if I stick that into my calculator, I get 5 over 2, or 5 over 2 squared plus 5 over 2 squared. So it's going to be 25 over 4 plus 25 over 4. So r squared is going to be equal to, I don't even need a calculator, 25, yeah, that's right. 25 over 4 plus 25 over 4 is 50 over 4. So r is equal to the square root of 50 over 4, which is going to be this, okay, the square root of 50 over 4. Okay, that's what r is going to be. Okay, we actually don't need r, okay, because the question said what's the equation. So I've got r squared is 50 over 4. So if I go back to this thing over here, okay, I had x plus 5 over 2 squared plus a y plus a half squared is equal to r squared. Okay, so now I know r squared is 50 over 4. So the equation becomes, okay, x plus 5 over 2 squared plus y plus a half squared is equal to 50 over 4. Okay, that question 4 is pretty much a section B question. Key idea, okay, don't forget, if you have a chord which subtends an angle of 90 degrees, okay, if you're told that, it means this thing is a diameter. If that's a diameter, what does it mean? Okay, that the center of the circle is your midpoint of your diameter. Okay, hope that makes sense. Okay, thank you very much.